Okay, for our next section, which is 1.5 from the book, it says slopes of secants, which we'll define in this video, and also average rate of change, which we'll discuss and come up with a formula for. So let's start with the idea of slope of a line, because slopes of secants are slopes of lines. Let's just kind of go over this main idea. With this slope of a line idea is hugely related to rates of change, which are hugely related to the idea of calculus techniques, which all of calculus is based on slopes. Okay, let's go through this problem. We can determine the rate of change of a graph by calculating its slope. Okay, so I've got this line, slope. Do you remember the slope formula? Yeah, you do. It's rise over run. Or sometimes in physics we say this is the change in y. So this is sometimes delta y over delta x. Okay, so all we're writing here is this is change in y divided by change in x from one point to the next. There's lots of different formulas. We've seen y2 minus y1, which is the change in y from a point to the one y value to the next, and x2 minus x1, which is the change in x, and that's why we've got that formula. I'll probably be using a formula that looks like this most of the time, that instead of using y, I'm going to use f of x. So I could say it's really f, an f of, say, x2 minus f of x1. So that's really just the y's, right? So this is y2 minus y1. That's what's going on there. And this is all divided by x2 minus x1, which is the change in x. So this is the change in y over the change in x. Oops, that should be an x. Okay, so these all three, or all 1, 2, 3, 4 of these are meaning all the same thing. I want you to make sure you take that note, especially this, because we've never really seen this format of slope, and also physics does not use that format of slope if you were a physics student, not traditionally. And I'm going to be using that today. Okay, so if I'm going to calculate this particular slope, if I got a graph, all I'm looking for is the change in y over the change in x. So I see a point here at 2, at the y-intercept, and I see another point right here at what looks like 5, and all I want to know is the slope. So I'm going to go rise and run, or the change in y over the change of x. Okay, so the change in y over the change in x is, the change in y would go from 2 to 5, so this is 5 subtract 2, and the change in x is from 1 to 0, so 1 subtract 0. So that's y2 minus y1 over x2 minus x1. Notice also it's really f of x2, because since x2 is this point here, f at 1 is 5, so that's that point there, or sorry, yep, and then f of x1 is right here, that first point. F at 0 is 2, and that's the value right there. Okay, so we got 5 minus 2 over 1, so this is 3 over 1, which is 3. So the slope of that line is 3. And then make a note here that, you know, the graph, the straight lines, the slope is a constant number. It's always the same. The rate of change is also a constant. Okay, so let's keep going. So if we have a curve, it's a little different. And this is, we've never really talked about slopes on curves very often, and this is our first introduction to it. If you got a curve, notice that the slope changes from 2 points. And what I mean is that slope is still, we're going to use the slope formula. So if you look at from the origin here to, say, this point here, a line drawn between those 2 points has a particular slope, which is going to be different, say, than I draw a line between these 2 points, right? It has a different slope. One is up, one's down in this case. So we have a changing slope on a curve. But we can still determine what we call as its average rate of change. Okay, so average rate of change is really just calculating the slope between 2 points. That's average rate of change. Okay, so we want to know how much does it change on average from here to here. Well, we're just going to find the slope of a line between those 2 points. That line, that when we draw it on a curve, is called a secant. So if I look at this particular example, when I plot this point here at 1, 3 and this point here at 4, 0, that secant line is just a straight line that goes through 2 points on a curve. The slope of that line is referred to as the average rate of change between those 2 points. So we can determine the average rate of change between these 2 points by finding the slope of that line. Okay, so I could say m for slope, or sometimes we use a, average rate of change, like this. They mean the same thing. So what we're looking for is, if I use the slope formula, which is our change in x over our change in y, I'm looking at what is the change in y's here, so I can write it in my formula. Well, I'm going from a 3 down to a 0. Okay, so I'm going down, a change in y would be down 3, so I have a slope of, or a rise of -3. Or if I use my points, this is my second point down here. This is f of x2 would be the y value at that point, which is 0. F of x1 would be the y value at this point, which is 3. So subtract those, that's my change in y. Divided by x2 minus x1, the change in x. So there's our x value here is 0, or sorry, it's 4, and our x value here is 1. So our average rate of change between these 2 points on this curve is -3 over 3, which is -1. The slope of that line is -1, and its average rate of change is -1. Okay, here's another example. Oh, I just did this example. So let me change it up a little bit. So say I wanted to find the average rate of change, instead of between 1 and 4, I said now between 1 and 2. Okay, so on the exact same curve, I got the red line on the curve, and by the way, on this particular diagram, the blue line is a secant line because it passes through 2 points on a curve. We're going to get into defining this other line, which only touches this curve at one point, and we call that a tangent line. Okay, so that's something different. But today we're going to be focusing on just secant lines, which are, remember, a straight line that passes through between 2 points on a curve. So if I'm going to do my average rate of change between 1 and 2, so at x being 1 is there, f at 1 is that value there at 3, and x being 2 and f at 2 is that value there. So if I draw my secant line, it's going to pass through those 2 points going up that way. And notice, since it's going up to the right, I already know that my average rate of change, which is the slope of that line, is going to be positive because it's going up to the right. So my average rate of change is my calculation of, now I'm going to write my formula here, f of x2 minus f of x1. And remember, all that means is it's y2 minus y1 divided by my change in x, which is x2 minus x1. So I got put in f at, let's put that as our second point up here. So x2 is 2, so f at 2 is 4. So put in 4 minus f at 1, which is 3, divided by x2, which is 2, minus 1. 4 minus 3 is 1, 2 minus 1 is 1. Our rate of change on between those 2 points is 1, which is also the slope of the secant line. Okay, one last one is, say I have a curve like this and I have an equation and I want to know what the average rate of change is between 2 points on the curve. But instead of using the graph, which is sometimes not accurate, we could use the equation. So say I have this polynomial and we need to use that to determine that slope of the secant line. So remember that average rate of change, and this is where this formula comes in handy. That's f of x2 minus f of x1 divided by x2 minus x1, which is just a slope calculation. So now I need to know between when x is 1 and x is 3. So what I'm going to do here is I'm going to be a little more formal. I'm going to call that my second point when x is 3. I need to know the y value. I don't know it. And I don't have it on my grid to read off. So I'm going to say, I'm going to find out what f at 3 is, because that will be the y value when x is 3, minus f at 1, which I'll find the y value when x is 1. And then I'm going to divide it by 3, which is x2, minus 1. Okay, so I'm going to leave this like this, and I'm going to go over here on maybe some scrap, and I'm going to find out what f3 is. So I'm going to use this space here. So I got f at 3 is, I plug in 3, because that's how we find out the y. Plug it in the equation. So that's 3 squared plus 3 divided by 2. So that's 9 plus 3 divided by 2. That's 12 divided by 2, which is 6. So f at 3 has a value of 6. So this is 6 minus, now f at 1, I'll maybe do up here in this little scrap up here. F at 1 is plug in 1. You got 1 squared, which is 1, plus another 1 divided by 2, which is 2. Oh, sorry, 2 over 2, which is 1. So f at 1 is 1, all divided by 3 minus 1, which is 2. So this calculation gives me 5 over 2. So the average rate of change between 1 and 3 on that curve is 5 over 2, or 2.5. That's how we use our equation to do that. That's average rate of change.